Let's take a look at this problem. Got P is equal to negative 1/6 s to the third plus 3/2 s squared plus 20s plus 2. And we want to find amount S spent on advertising, $1,000, and maximizes profit P. So let's find our first derivative. Got negative 1/6, take our power, put it out in front, so we've got 3s squared plus 3/2 s squared becomes 2s plus the derivative of 20s is 20. So that gives us negative 1/2 s squared plus 3s plus 20. And we want to set that equal to 0. Find our critical values. So we got negative 1/2 s squared plus 3s plus 20 equal to 0. And I'm going to use a calculator. I'll be lazy. Now I'm going to do my convention. I'll put my my polynomial initial one, the function, on y1. So I got negative 1 divided by 6, x to the third, different variable, but same idea, plus 3/2, 3 divided by 2, x squared, plus 20x, plus 2. Okay. And I'm going to down arrow to y2. I'll press clear on that. And then we're going to put our first derivative on y2. So we've got negative 1 divided by 2, x squared, excuse me, plus 3x, plus 20. Now I'll put 0 on y3. Now I'm going to go back up to y1 and put my flashing cursor on equals and press enter one time. And that'll shut that one off. Now I'm going to do the intersect method. And I got y2 and y3 I'm working with. So I do second trace, choose intersect. Our answer is where it crosses the x-axis. I might not be able to get that one there. I might have to zoom out. Let me try this one. In our first curve, in our second curve, and I'll put a negative 4. That's what it looks like. Yeah, it is negative 4. So we've got s is equal to negative 4. The other one's probably 10, but let's try second trace, choose intersect, inner, let me put in 10. Okay, it is 10. Now these are critical values. Though negative doesn't seem to make much sense for this, we'll still work with it. That would imply you're getting money back that you're spending and not spending any. Negative infinity definitely doesn't make any sense, and positive infinity doesn't, but we'll go with that. So test cases. I don't really need to check this, but let me put in negative 5 over here. Here we want to choose test case between negative 4 and 10, like 0. And something greater than 10, but maybe easy to work with, like 20. And we want to plug that into our derivative. Well, my calculator, if I go back to y equals, remember our derivative is on y2. So if I do second graph and delete those, we got 0 inner and 20 inner. And y2 is our first derivative, so we got a positive and negative. Positive increasing, negative decreasing. So it is indeed a maximum. Now all they're asking about is what, and I did x there, but that should have been s. All they're asking about, I'm not sure why I changed variables. All they're asking about, though, is what value causes that. Well, we have a max at s is equal to 10. Okay. Now they're not asking us for the maximum profit. They're just asking what value of s causes that to give it. Okay. Well, now we want to find point of diminishing returns. I need to find my second derivative. Well, my first derivative is right here, so I'm going to continue taking derivative of that. So I got negative 1/2 s squared becomes 2s plus the derivative of 3s is 3. So that's going to give us negative s plus 3. Set that equal to 0 to find our critical value. Take negative s to the right side, and we got s is equal to 3. Now, 0 is an appropriate one to start with here, but I'll go with negative infinity. But I won't go into negative regions. I'll choose a critical or a test case between 0 and 3, like 1. And over here, I'll choose something greater than 3, like 5. Now, we want to plug those into our second derivative, which is right here. So put a 1 there. Negative 1 plus 3, that's positive. So this is going to be concave up. 5. If I put 5 here, negative 5 plus 3 is negative, so it's concave down. Your point of diminishing returns is when the concavity changes, which does change there. So our point of diminishing returns will be 3 comma something. Now I want to plug that back into my original function. And on our calculator, if I go to y equals, our original function was on y1, but we currently got it shut off. So I put my cursor back on equals and press enter one time. And now if I go to second graph, the table, clean up those values, I can put 3 in. 3 enter, and we're going to get 71. Color problem there, but should all been red. Anyway, those are our answers.